So when you have this kind of situation, right, you're raising something inside that has an exponent to another exponent. The rule says that you do this. And so what is this? What's going on right there?
Are you multiplying?
You are multiplying. So you're multiplying the exponents. Okay, that's basically it. Okay, so we're going to do a couple examples, and then we're going to do things that have everything to do with everything that we've done. Okay, so one problem will be a multiplication and a division and a power to a power and some negative exponents and stuff like that. Okay? Okay, so the only thing that's weird about these is, well, not weird, but you just got to make sure that everything inside is being squared. And so, you know, just like when you were doing the dividing things, don't get mixed up between your rules. Okay, we still need to square the 6 because we're still multiplying its exponent by the exponent outside. So I think that's a good way to think about it. What is the exponent of each of these inside?
6.
What's the exponent with the 6?
Exponent
1. Okay, so really, right, this is 6 to the first, x to the first, y to the first, all squared, right? Okay, and so then that rule says that we multiply all the exponents. So then this is 6 to the second, x to the second, y to the second. But what is 6 to the second?
36.
So then this is really 36 x squared, y squared. Is that okay? And so, you know, you don't really have to do this if you understand what's going on, right? You're squaring that. So it needs to be 36. As long as you understand that why it's 36, you can do this step if you want, or you don't have to do that step. But that's why it's 36, because the rule says take this power that's outside and multiply it to every power inside. Okay, and like a further explanation of that is, what does an exponent do? Well, yeah, it multiplies the base by itself that many times. So really this is 6xy times 6xy, right? And so then it'd be 6 times 6, which is 36, x times x, right? Multiplying like bases, add the exponents. Multiplying like bases, add the exponents. Okay, so that's why it goes like this, but it's, you know, just a little quicker. Is that okay? Okay, and you can't look at these things all at once and get all worried. You can only do certain things at once, okay? And, you know, order of operations still counts, so that means we got to do it with our exponents outside these parentheses first. So what do we do with this 3 compared to the things inside?
Do you do something with the exponents on the inside with that one on the out?
Yeah, let's do that. Okay, so this is kind of, you know, just look at this like it's this problem, right? If you're okay with this problem, then all you're doing right now is just looking at this right here. Don't worry about all this over here yet. This right here. What do you do with these exponents? Right, we're raising a power to a power.
Would you subtract them or multiply them?
Well, what's the rule? What's the rule for the power to the power? What do we do up here?
You multiply.
Okay, so let's do the same thing then. So then this one is a to the what?
Negative 15.
Okay. B to the...
6.
All right, now let's do the same thing on this one. We can do it at the same time. This is a to the...
8. And then e to the negative 2.
Okay, is that okay? Now we're not done, but now we're switching, okay? So, again, these aren't hard. They're just a lot of steps, and maybe you're trying to do too much at once. We are now multiplying, right? There's nothing in between here, so that means we're multiplying. When you multiply like bases, what do you do to the exponents?
So you subtract it.
When you add, right, when you multiply like base. Okay, so a to the what?
Negative 7.
Okay. B to the...
4.
Is that okay with everybody? Now, of course, you can't be done because you have a negative exponent. So we have one more.
So it's b over, b to the fourth over a to the second.
Yeah, good job. Does that make sense?
So 3 different rules in that one.
Yeah, so 3 different rules and kind of like 4 different problems, right? Right, here's a problem, 2 problems, now we got 3 problems, and here's the 4th problem. Nothing by itself should be that big a deal. Okay, so kind of looks like a lot going on, but just work inside the parentheses first and just start with the coefficients.
We're multiplying.
But start inside first. Because, it doesn't matter which way you start.
Well, I didn't know if you wanted to like multiply all that and then put it over each other and then divide them by.
Okay, so that's perfectly fine. You can absolutely do that. There's no rule that says that you have to go inside right now. Okay, I'm going to go inside because I'm going to make those smaller before I multiply. But if you wanted to multiply, you'd still get to the same answer. Okay, but let's do it this way, and maybe we'll do another one. We can do it the way you're talking about, and you can decide on your own. Okay, so can we reduce 3 over 9? What's that reduce to? Well, 3 over 9 reduces to, how about 1 over 3?
Oh, yeah.
Okay. And then now we're dividing like bases here, so what do you do to the exponents? Well, let's just do the division rule. Okay, so -2 minus a -4 is, what is it?
-6.
You're not adding, you're subtracting.
-2.
How about +2?
A negative minus a negative is a positive.
Well, it's the second one's bigger,
-2 minus a -4.
so that's really -2 plus 4. What about the b? What's the exponent with the b?
It's just 5.
Okay, right? 5 minus 0. So now you got less to multiply. That's what I'm saying. All right, so do we need this 1, firstly?
Not really.
Not really, okay. So what's the exponent with this 3?
-2.
Well, before you do that, though. Like inside right here, what is it right now? 1. What's the exponent here?
2.
And then 5. Okay, so now we're going to multiply all of these exponents by this -2, right? So then it's going to be a to the what?
-4.
B to the
-3.
over 3 to the...
-2.
Is that okay with everybody? All right, now, of course, we have a bunch of negatives, so we can't have that. All right, so what is it then?
On the top would be, actually, I don't know.
Yeah, you do it.
You do?
Yeah.
So 3 to the second.
All right.
power, I think that's okay.
Yep.
Top, and then a to the 4th power, and b to the 10th.
Okay, and this would be a fine answer, or you could change it to 9 over a to the 4th, b to the 10th. If it's something really easy, like 5 squared, 3 squared, then go ahead and do that. But if it's 8 to the 6th power, don't worry about that. I've never counted wrong either way, but it's easy to switch that to a 9. Is that okay? All right, so let's do one like. Right, so the other option would be to multiply all the exponents first. So then we'd have -4 to the.
About the exponent for -4.
Okay, so to the -4, right, because there's a 1 here now, and we distribute that in. Okay, and then we'd have x to the,
Makes it a lot bigger.
16.
so -16, right? So now you're just going to get bigger numbers, and so then it would be y to the over 5 to the
-4.
x to the,
-4, and then -16.
Okay, so now I would do probably your like bases, right? Dividing like bases. So we'll leave this -4 to the fourth, and we'll leave the 5 to the, oops, that's the -4th, to the -4th. So what about x to the -16 divided by x to the fourth? What does that give you?
Is that 4? -4
Don't divide yours. When you're dividing like bases, you subtract the exponents.
I always do that.
Don't do that.
-12.
Negative what?
12.
What?
12. Is that not 12?
It's just funny, because he was like, what? And then you keep saying the same thing like he didn't hear you.
Because like you. Is it -20?
Yeah. Then y.
How do I keep doing that?
Gary did the
People-
same thing.
Yeah, people don't like negatives. Y to the what?
-24.
To the what?
20. -20.
8 minus a negative.
Literally, I swear.
8,
-8.
8 minus a negative, minus a negative.
Multiplying.
She's so confident in her answer. The other part is like -8. -8.
Where's that?
That's 24.
Oh.
Because we did 8 minus -16.
So it's 8 plus
Two
16.
negatives make a positive.
It's 8 plus 16.
Because it's 8 minus 16, minus a -16.
I said 24.
No, you said -24.
Oh,
All right, but we do have negative exponents. This is a negative right here too. All right, so to finish it off, what do we get?
okay. Well, are we ever going to multiply the 4 and then
Well, okay, so this would be 1. I mean, that gets to a fairly big number. I mean, I think it's,
or do you just
So we can just move.
yeah, so let's just move it and then we'll be okay. All right, so then what's in the numerator here?
Answer the question.
What are we moving?
What, yeah, what's moving, what's staying the same?
So the -4 to the -4, you're keeping that on top?
Is there a that's a negative exponent up there though.
Yeah, but.
We're not
so
changing the
gonna-
number,
We're not gonna make it
Oh, we're not
4 to the
changing
4th,
it.
yeah.
but we
So-
have to move it.
So it's going to be -4 to the 4th.
Where?
What would it be?
Where?
Well, on the bottom.
Okay. So -4 to the 4th down here.
And then x to the 20th
Where's that?
on the bottom.
Okay.
And then you keep y to the 24th on top, and then 5 to the 4th.
Okay. So it doesn't matter which way you choose to do it. You just have bigger numbers to subtract. I mean, it's no big deal. Okay. I usually try to get less places to multiply. But whatever.
Obviously.
Is that okay?